So my name is Willem Elbers. I'm representing the Social Sciences and Humanities case study. I will briefly start with a little bit of context into the relevant services for our infrastructure that we've used in this case study. So there's the virtual collection registry. This is a service where we create virtual collections, bookmarks to resources in repositories, across repositories. And we try to make these collections citable. So we assign a DOI to this collection to promote its reusability. Another service important to this case study is the switchboard, or the language resource switchboard, which basically is a broker between data and tools. This service, you upload data or you provided a link to some data. It will do some analysis, check the data type, the language used in that data, and based on those properties, it will make a suggestion as to what tools are available in our infrastructure that can operate on that data. So this really is an explorative tool for our users. And finally, we have the Digital Object Gateway. This is an API that we use within our infrastructure to interface with all kinds of PID systems and repository systems. And the aim is that it should provide like a single API into these various systems. To highlight the benefit of using the components in our case study, I will discuss two user scenarios. So a typical workflow for us is a teacher that is preparing a lecture, and in this lecture requires some resources to be used. That teacher will create a virtual collection, add all the links to the collection, and in the lecture itself, then use this collection for the students to get access to all the materials. This works well, but there's some limitations to this workflow. So adding these links to the collections is all manual work, and we will require some metadata that has to be provided for each link in the collection. And especially if the amount of links grows, this is quite a bit of work. So ways to optimize this workflow would really benefit our users. So what we did, we integrated the virtual collection registry with the PID meta resolver. Originally, we only supported handles and DOIs in the virtual collection registry. So you can add a URL to a resource, or you can provide a PID or DOI. By integrating with the PID meta resolver, we basically expanded the amount of supported PID systems with quite a bit. The table is not extensive, but it shows a little bit what we supported initially. That's the DOG or Digital Object Gateway column, and the other column, the PID-MR column, shows basically all the systems that have been added by this integration. We have also integrated with the data type registry, and in the data type registry, we've defined an extended data type, which allows to also provide some links that are relevant for the data type. Can be RFCs, can be schemas hosted in the metadata schema crosswalk registry, or even direct links to crosswalks. And we basically use this. If a user adds a link, we analyze the link, and we try to map that to a type, to an extended type in the DTR, and then use the information there to directly find the schema or the crosswalk in the MSCR. And if we have this crosswalk, we can actually run it on the link that was provided by the user, and basically convert the metadata to a schema that we understand, and extract useful information like the title, the description, and the author, and pre-fill all of this information into the link added to the virtual collection. So there's a screenshot of a technical overview, but what you can see is that based on some link added, we found a data type in the DTR, and we found the crosswalk, and we basically use that to extract some relevant information automatically. Another use case is for where like a technical or more technical skilled researcher is interested. It has a collection of resources and is interested